Hans Goldmann, in eye care, a brilliant scientist and engineer. His legacy lives on, front and center of intraocular pressure, and a clear understanding of his technology and the way it was constructed is required to assess its ability and shortcomings in diagnosing and treating pressure-related diseases. Goldmann applanation tonometry is an approximation of intraocular pressure and remains the standard by which IOP is measured for 65 years. Goldmann demonstrated that the simple Imbert-Fick formula can be corrected to measure IOP, accounting for corneal stiffness and corneal tear film adhesion. A flattened diameter between 3 and 3.5 millimeters produced a zero net force between tear film adhesion and corneal deformation in average human corneas on cadaver globes. He acknowledged that variations in the corneal deformation force and tear film would result in significant error. Today, we can more accurately measure pressure in live human eyes. So this is what we did. We measured 58 live human globes undergoing cataract surgery with a modulated IOP and placement of an intracameral pressure transducer. We were able to determine that the original design was inaccurate with a bias of Goldmann measuring 4.5 millimeters of mercury less than the intracameral pressure. Now, what does this negative 4.5 millimeters of mercury inaccuracy really mean? Well, nothing. It's baked into the cake. All studies and historic references now have this bias included. However, the imprecision of more than 3 millimeters of mercury at one standard deviation is a legacy which, if ignored, can lead to presumptions about IOP, which are artifacts of this imprecision. Using the variability observed when comparing intracameral pressure and using Chebyshev's theorem, we can predict the minimum probability of a given level of error. At least 76% of IOP measurements will have an error exceeding plus or minus 2 millimeters of mercury. At least 12% will have an error exceeding plus or minus 5 millimeters of mercury, and at least 2.5% will have an error exceeding plus or minus 10 millimeters of mercury. These can be significant errors when considering your daily assessment of ocular health. Since Goldmann's original publication about applanation tonometry, our science has evolved to segregate pressure-related diseases by Goldmann IOP alone. This is seen in both ocular hypertension and normal tension glaucoma. As an example, what is the probability that your normal ocular exam at an IOP of 20 millimeters mercury is actually ocular hypertension? Well, it's at least 37%. Likewise, at what we feel is a very safe IOP of 13, there is at least a 4% chance that they actually have ocular hypertension. These are sobering probabilities which can challenge scientific findings predicated upon IOP as being biased by IOP error. These same IOP measurement errors exist in the designation of normal tension glaucoma, which is also based solely upon Goldmann IOP. But the difference is that there is a concomitant observed disease process of glaucomatous optic neuropathy. So the probability that your normal tension glaucoma is actually primary open-angle glaucoma at a measurement of 19 millimeters of mercury is at least 17%. And at 16 millimeters of mercury is at least 7%. But here's the catch. These low IOP measurements are also dependent upon the observation of glaucomatous optic neuropathy. So this pre-selection bias could push the IOP error in this population significantly higher, even approaching 100%. These findings challenge the prevalence and perhaps even the existence of normal tension glaucoma. The takeaway: as we look for the multitude of other contributing glaucomatous factors, such as vascular insufficiency and intracranial pressure, the challenge for our generation is to increase the precision of our IOP measurement. IOP appears to be the dominant causative factor, and this imprecision can lead to artifactual and possibly false findings, which may be due to an incorrectly measured IOP. Thank you.